Hi there. Today we're going to do scientific notation. Objectives. We're going to express numbers in standard form and in scientific notation, and we're going to compare and order numbers written in scientific notation. Our standards are we need to know and apply the properties of integer exponents to generate equivalent numerical expressions. We're going to use numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or small quantities and to express how many times as much one is than the other. And then we're going to perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. Use scientific notation and choose units of appropriate size for measurements of very large or very small quantities. The vocabulary you need to know today is standard form and scientific notation. Key concept, scientific notation. A number is expressed in scientific notation when it is written as the product of a factor and a power of 10. So we have a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So we're basically looking for a number that's between 1 and 10. So the form is a number, a, times 10 to the nth power. So an example is this large number, 3,500,000, and we're going to write it times a number times 10 to the power greater than 1. Okay, same thing here. This is a very small number, so we're multiplying it times a factor times a power of 10. Numbers that do not contain exponents are written in standard form, which is just a regular number. Just like when you deal with very large numbers like 12,760,000 or very small numbers like 0.00001276, it can be difficult to keep track of the place value. So a number that is expressed as a product of a factor and a power of 10 is considered scientific notation. When a number is expressed in scientific notation, the exponent tells you how many places to move the decimal point. Here's a helpful tip. When you're multiplying by a power of 10, you're going to move the decimal place to the right. And if you're going to divide by a power of 10, you're going to move the decimal place to the left. Express each number in standard form. Okay, remember standard form is just a regular number, and these are considered scientific notation because it's a product of a number, a factor, times a power of 10. Okay, so we know that this is a positive exponent, so we're going to be moving the decimal place to the right. Okay, so we have the number 2. We're going to move it 3 spaces to the right. So 2 times 10 to the third power is 2,000. 6.8 times 10 to the fifth power. Again, this number is less than 10, but greater than 1. And then, so what we have here is we have 10 to the fifth power. So we're going to have to move the decimal point 5 spaces to the right. So now we have 6.8 times 10 to the fifth power is 680,000. Again, we moved our decimal places 5 places to the right. Now, in the case of negative exponents, we're going to be moving it to the left. So we're going to take this number where the decimal point is, and we're going to move it 4 spaces to the left. So 3.25 times 10 to the negative fourth power is 0.000325. Now we're going to take our regular numbers and we're going to put it into scientific notation. Our first step is to put the decimal place after the first digit. That's how we make sure that the number is less than 10 or equal or greater to 1. So we're going to write put the decimal after the first digit. We're going to drop all the zeros, whether it's before or after. We're going to find the exponent, and that's basically the number of places you had to move the decimal. If the number is greater than or equal to 10, the exponent is positive, and if the number is less than 1, the exponent is going to be negative. And then we're going to put it all together in the form of the number times 10 to the whatever power. Okay, so our first example is 4 million. So the first thing we're going to have to do is we're going to have to place the decimal point right after the first digit. So we're going to have our decimal point like right about here. Now the question now becomes, how many decimal places did we move it? And is it going to be positive or negative? So we know it's going to be positive because the number is greater than 1. So how many decimal places did we move it? Well, it was over here, so it's going to be 1, 2, 3, 4, 5, 6. So we moved it 6 places. So it now becomes 4 times 10 to the 6. Again, it's positive because the number is greater than 1. All right, so here's our other one, 0.072. We want to have one decimal place or one place value. Usually it's going to be in the ones place. So we're actually going to place our decimal right between the 7 and the 2. So from where it was, how many decimal places did we move? We moved 1, 2. Now is it going to be positive or is it going to be negative? It's going to be negative because the number is less than 1. So here we go, we moved 2 spaces. That's why we have 10 to the negative 2 because the number is less than 1. And we placed the decimal between the 7 and the 2 because we wanted a 1 number in the ones place. The population of Kansas is 2,853,118 people. Write an estimation in scientific notation for the population. Now, when they're talking about estimation, they usually just want one place value. So we're actually going to estimate this number to 3 million. All right. So we're going to say this is about 3 million. And we're going to say to ourselves, okay, um, how are we going to write this in scientific notation? Well, we want one decimal place. So, or we want one digit before the decimal place. So we're going to plot it after the 3. How many decimal places did we move? So we went 1, 2, 3, 4, 5, 6. So it's 3 times 10 to the 6th power. So the population of Kansas is about 3 times 10 to the 6th people. The space shuttle traveled about 8 kilometers per second. At this rate, the shuttle would have taken about 4.5 times 10 to the 4th power seconds to fly to the moon. Is it more appropriate for a newspaper to report this time as 4.5 times 10 to the 4th seconds or about 12.5 hours? Explain your reasoning. So this is what we're talking about when we're trying to discuss an appropriate unit, either scientific or standard notation. So if you're going to be talking about this to people in a newspaper, what do you think is more important? A very large number or a very small number using the units? Okay, so the measure of 12.5 hours is more appropriate, and that's because 4.5 times 10 to the 4th seconds, that actually equals 45,000 seconds. It's a very large number, so choosing the larger unit of measure was a little more meaningful. So we didn't want to use the smaller unit, which was seconds. We used larger. So that way people can kind of relate to it rather than saying 4,500 seconds. 12.5 hours was a little more relatable. Compare and order numbers. To compare and order numbers in scientific notation, we're going to first compare the exponents, okay? Smaller exponents means a smaller number, and in the same token, larger exponents mean a larger number. With positive numbers, the number with the greater exponent is greater. If the exponents are the same, we're just going to compare the factors or just the numbers. So here's an example. They're showing different geological time periods. We're going to order the time periods from the oldest to the youngest. Okay, so here we have Jurassic, Silurian, Tertiary, and Triassic. First thing we're going to do is we're going to compare the exponents. Obviously, the smallest one is 10 to the 7th power. Okay, because that is a smaller exponent. So that's the youngest period. Now we have to compare the other ones. Now these all have 10 to the 8th exponent. So after we do that, we just have to compare the factor, or I just like to call it the number. So if we're comparing them, we know that Silurian is greater than Triassic, and that's greater than Jurassic. Okay, so the time period from oldest to youngest is Silurian, then Triassic, then Jurassic, and then our youngest one with the smaller exponent was Tertiary. Hope that video was helpful. Thank you. Bye.